Welcome back to Bal Vigyan Bharati. Now, as I already taught you regarding a new concept on probability, that is conditional probability. Now we'll learn another and conditional probability. We have already shown you an example to make it understand. We'll show some more examples later, but prior to that, one more theory that is related to the conditional probability has to be explained, so that it could be a cumulative learning for you, which is of similar, you can say, the concept. And this theory, the theory name is Bayes theory. So now this theory is based on the prior concept, that is conditional probability. So, but why this is needed? Now, if you see the conditional probability, there we learn that probability of any event in another event which has happened already is depends on the intercept of that event with the other event, and the probability of the other event, if I do the ratio of these two, so we'll get this one. Now the Bayes theory tells you, if in case you have a sort of information regarding this intercept A, intercept B, sort of information, then whether the probability of any event in another event, can it be such that they are interdependent within themselves only. That means, if I want to calculate the probability of A in B, can it be represented such a way that if we know only the probability of the individual events, whether it is possible to calculate. Now we'll do on this part, and this part is being invented by Robert Bay, and this is named after him only. So he has done a little improvisation of this conditional probability. What he does, let's say again we are talking about two events A and B, and the first of the information that is coming from the conditional probability is, if it is named as equation 1, where this is made like this. Now what he has done, he has just simply reversed the equation by replacing A with B and B with A. If we do that, our equation will stand like B intercept A and P A. So I am just replacing A with B and B with A. So this will be my, and how physically it is possible. Actually earlier we have shown, if it is the sample space and there are two events B and A, where this is the intercept part, this is B, this is A. What I has told that if B has happened earlier than A, then that equation follows this way. Now this could also possible that A has happened earlier and B is following, so then this is also true. Now here we can see, during our earlier discussion we have already told that A intercept B and B intercept A does have same meaning, because this will represent the same intercept for both the cases, because A and B are interrelated events that I have told, and the intercepts are the common space between A and B. So in this case, A intercept B and B intercept A delivers the same result. So can we replace, can we equalize, or else one step more, if I put, instead of B intercept A, we can put A intercept B in this equation by with a simple logic that those are the same area represented. So in this, now if I compare 1 and 2, we can see, and if I equalize this two part, because probability A intercept B, there also intercept B, what does it tells? Probability of A in B, and if we multiply it with probability of B, that equalize with probability of B in A, and I multiplied with P A basically. So this is my equation, which is named after Bayes theory. Okay, you can call it a third equation, and you can see the similarity is that if P a probability of A in B into PB, now is remembering is very easy. B is in the denominator here, and B, now if you cancel that, you will get PA, and the same result, and the probability, once if it is not practically the same, but to remember it, you can cancel the thing which is multiplied here. To just remember, I'm giving you some idea, but this is not the actual meaning of that. But what is that? P, probability of A in B into probability of B, is equal to probability of B in A into probability of A. So this is the equation. So now you can see these are not dependent on the intercept part, rather they are individual. Now if I want to calculate probability A in B, it will depend on probability of B in A into into probability of A divided by probability of B, or otherwise this can also be treated when we want to calculate probability of B in A also. So now what is the use of this? Now the use is of that, if I make an example of such event, let's say for example, if I say in any let's say an area, any place, area, not this let a place where the raining probability is 15%. Okay, so in on the throughout the year, whatever rains is occurring there, on that basis that is being established that the raining probability of that area for the whole year as having 15%. So if it is the criteria whether people can decide picnic, let's say picnic outside the home in that area, this probability 15% on a certain time, okay, on a certain time. Okay, now people want to get into the picnic outside the home, and depending on this probability in that area, and whether can decide picnic outside the home in that area on the data available. Now with this percentage of information, whether it is sufficient to decide for the people to go out on that certain time. Let's say it is a mid of the year, where the probability of the raining is 15%, and on that day whether people will decide to go out, whether they can take that decision comfortably or confidently. This is my question. So now, is this sufficient for that? So now there are one event A, if I say raining, that depends on the whole year, the probability of raining on that particular time of the year is 15%. Now there could be another event, cloud cloud outside. So that also give you some hint whether probably the raining will happen or not. That will be added advantage or the event that may tell you the fact that there would be any rain or not. And that also having some percentage, let's say 30%, let's say, cloud outside. By seeing that, people can take and wherever there is a cloud, with this the event is the cloud and rain together. Once wherever there is a cloud, generally rain comes. That is the probability of 30%. And the other criteria, let's say C, an event where there is a bright sunny day and it could rain. That also another part where the probability, let's say 10%. So there are more things. If want to take decision by seeing the cloud, rain probability is 30%. So this is an added information on that. In that certain time, 15% is generally raining, and if someday cloud is outside and probability of getting rain is 30%, and if on the same time, if it is a bright sunny day, rain comes, it is 10%. So this is added advantage. Now whether deciding on this factor or cumulative of this factor will give you a certain hint of a major probability of getting rain. Okay, so now we can say if it is a sample space, let's say, now what are the criteria? There is a fact B, let's say, cloud and rain, and there is another fact, bright rain and rain. So this is the common intercept, the rain may come. Okay, so this is B intercept C. This is the part B intercept C. This is B where cloud and rain, and this is C where bright and rain may come. Now the probability that at any day, if I see and on a certain day, if we see cloud, so whether that cumulative result will tell you there will be rain or not. So the probability that we want to get cloud and rain, this is my criteria, where the probability cloud and rain, that is the probability of rain when there is a cloud. Okay, this means if I follow the formula, probability of getting let's say A is said to be raining. Okay, so this is pure, what is that, PR, raining, and this is P of cloud and rain, and this is P of bright and rain. Now I have seen that day there is a cloud, so I want to get the cumulative effect of cloud of rain is depend on the probability of rain when there is a cloud into probability of cloud divided by probability of rain here. Okay, so probability of rain when there is a cloud means cloud and rain is no, means I have to calculate the rain when there is a cloud. That probability will be P cloud and rain, because cloud, I have seen cloud and rain is 30%, because this is the known factor, it is known. So I need to decide whether rain will be there if I see cloud. The cloud is already happened. This event has already happened. You can see cloud outside. Now I have to decide whether there will be rain or not. So that is depend on the when there is a cloud, there is a rain. That you know. Okay, into the probability of raining. It is general case and divide by probability of cloud. Okay, these are the case. Now this probability of cloud and rain is 30%, that means 0.3 into probability of rain is 0.15, and probability of cloud you can see there is a cloud outside, that means uh, you can see it outside, so that means it is already 100%, means there is no probability this is happening, that means it is 1. You can see it outside because there is no probability, you can see it, the fact is happening. So probability of getting cloud, that does not depend on any number, means this probability is already you can see practically, so this is 100% happened. So this is a practical situation, there is no probability because you can see cloud. Now if I calculate this, it will come 0.45. so that means on this all situation, if I see cloud, that the most probable that rain will happen when you can see cloud is 45% is coming. That means if any information which is telling that raining for the whole year on the basis of the whole year on that certain time, the mid of the year, let's say the mid of the year, mid year, probably 15% is raining, but for particular day on that basis of two more criteria, whether cloud and bright, there are some information is already there, and you can see there is a cloud outside. So on that basis, if I want to decide and over the whole criteria, I can see the most probability 40% is chances of raining. So now if we can decide on this, your decision will be more perfect than if you decide on this. If you have only this information, your decision may go wrong, whereas if you see this percentage, you will hold yourself a bit because this is almost coming a 50% of the chances. So your decision will be more crisp and confident that you have to go for a picnic or not. Understand? So this is the end of this class. In the next class, I will move forward with more number of example on these two subjects. Okay, so thank you for now.